Our first presenter in the second half is Advirna Oncology.
Okay, first of all, I would like to thank the organizers for giving us the opportunity to present our technology and our company. Advirna is a technology platform company working on the RNA interference. RNA interference, it's a Nobel Prize-winning gene silencing technology. You see the depiction of our molecules. It's a short chemically synthesized RNAs which are capable of inactivating any gene you want once it's get inside the cell. It's very powerful technology to knock down genes. The trick is how to get it where you want. And we do it by attaching these molecules to a nice targeting sequence, which is ligand. With this ligand, we make these molecules to get inside cells. This technology has enormous breadth of applications. Advirna was focused on using this technology as a research tool to provide the third parties with therapeutic leads or just technology for research. But as any CRO, we were dreaming about developing our own therapeutic projects. And I must say that additionally, Advirna has the experience of creating a therapeutic spin-offs based on the same RNA technology, and one of them we created 4 years ago, and 2 years ago it was successfully acquired. So I do have some therapeutic experience as well. Okay, so what's important about immunotherapy for dogs? I guess everyone in the audience knows about the revolution in oncology which was happening in the last 10 years, specifically in the immune oncology, with development of monoclonal antibodies targeting what's called immune checkpoints, or with development of cell therapies. Everybody, I guess, knows about what's a CAR T cells. This is engineered patient T cells which target tumor antigens. Basically, they're killing re-educated T cells to kill cancer cells. But these novel technologies absolutely cannot be applied to our best friends, to dogs. Why? Because the technologies that they develop, they are human-specific. They cannot work in other species. You cannot take human antibody, inject it in dog, and expect it to work. It will not. And to develop these technologies is extremely expensive. Also, the treatments, as you can see, are very high, the price of treatment. So it can be applicable for any veterinary applications. So we need to come up with a solution which will bring the power of, let's say, immune oncology to treat dog cancers. And I guess our technology can do that. So we started with one kind of type of dog cancer, it's dog's melanomas. It's absolutely deadly for dogs, and there is no cure. What is the kind of size of the problem, size of the market? So there are 6 million dogs in the United States only which are getting cancer every year. 10% of them melanoma. Melanoma, as I said, is a death sentence. There is no cure. The total market of oncology is estimated to be about $300 million in 2024. It's only US. And we are talking about probably 10% of that market, which is a melanoma, but giving only the existing treatments. What's important, in the middle, there is a depiction of a tumor. When tumor develops, it develops because of a catastrophic failure of immune system. It cannot recognize cancer cells. And to restore the immunity and to induce immune response, we have an opportunity to introduce our RNA molecules, RNA triggers, inside the tumor. So we will restore the failures of the immune system. And our technology has multiple advantages over whatever biological ones. First of all, the cost of our treatment for dog is expected to be well under the $1,000 per treatment. Technically, it will be more to the hundreds. And we can target multiple targets at the same time. So it will be probably the only affordable technology. So our company, so we have we work in the field for several years. We have very strong intellectual property portfolio containing of like all 15 patents, has exclusive rights for veterinary applications. We already generated multiple compounds. Some of them are in clinical development. Our business model is pretty simple. We are going to develop our compounds to the equivalent of stage 2 in dogs. And of course, and then we out-license or the company will be sold. We are, of course, looking to the human therapeutics eventually. And we expect to develop our products in about 2.5 years, and we're looking for about $2.5 in investment.
Alexey, at least I remember we've met through WPI, so at least
That's
I
first
some
time, yes.
memory.
My
in
second time
memory.
here.
All right, so what about the diagnosis of cancer? I mean, isn't that probably one of your bigger challenges? The fact that first of all, you obviously have to diagnose the cancer in the canine, or know they have cancer before you can treat them, right? So is that an issue, or how much of a challenge is that?
Well, of course, it's an issue, but basically, so your dog is kind of, so I had a dog, my dog actually died of cancer. So it's kind of getting tired, you don't know what's going on, and you are trying to do something to figure it out, what it is. It takes time, and there are no such of like diagnostic tests developed for dogs for the same reason. It's very expensive to develop. So mostly it's based on doing X-rays and kind of old-fashioned medicine. So, especially with melanoma, it's almost always developed inside the mouth, or the skin is dark. You don't see it until it's too late. When you see it, it's pretty big. It means it's inoperable at that moment.
Thank you for your presentation, Alexey. I really enjoyed it. I have a question about the safety and efficacy. I know it was on one of your charts, but I don't know that you went too deep into it, but I missed it. Can you talk about the steps you've gone through to demonstrate the safety and efficacy in dogs? My other question is, you're specifically targeting dogs. Is that your entry point, or could this apply to other house pets like cats, for say?
I don't think the economics will work for cats. For dogs, if people are going into oncological treatments, the price tag would be about $10,000 per treatment. And it might include surgeries, radiation, chemotherapy, and so people are going very long ways to keep their friends alive. Mm-hmm. So with cats, I don't think so it will work like that. And to develop something like a modern therapeutic, you need to have a pretty high price point. So, and that's our advantage, what we develop, because to our estimates, the cost of goods for treatment will be within $100 to $1,000 per patient, okay, which makes it affordable in terms of comparing to current treatments.
Okay, thank you. Can you talk a little bit about the safety and efficacy that you've demonstrated so far for dogs?
Well, as I said, so what I'm presenting right now is a concept. So we are in this field for a long time. We know how to do it. We have pretty experience in developing therapeutics. One of my companies using the same technology, has been already acquired after we demonstrated the proof of principle. So we know how to develop therapeutics. We do not have precisely lead molecules for the targets, but for us to create leads, it's a matter of months. Well, Taisi might not disagree with me, but Taisi is a scientist who is doing all the work. I'm doing the talking. So, so she always more pessimistic. But technically, in half a year, we can come up with the leads. That's the advantage of technology. It's very fast to come up with leads. Development cycle is much shorter.
Okay, thank you. That's helpful.
And in the development then, in the technology that you're using, is there something that makes it particularly effective for canines versus humans?
Not at all. It's just the same thing, that canine melanoma it's a medical problem which requires solution. Melanoma biology is pretty well studied both in rodent models and in humans, so we exactly know against what targets to go after. And technically speaking, we have already some of the surrogate molecules against mouse targets already developed. So that's kind of, there is a medical need, and I guess for melanoma specifically, the immuno-oncology approaches will be the most effective.
And so the siRNA technologies that other people are developing for human applications, I mean, they could potentially also be used for canine?
Well, yes and no. The same molecules most likely will not work because they're almost always species specific. So you'll have to develop compounds which will be canine specific against the same target, yes. But the same molecule most likely will not work. This is like antibodies.
Thank you, Alexey.